Here's a basic normal distribution question that we're going to use to actually make a little bit more sense of what's happening with this whole normal distribution thing. So we've got the length of drives are normally distributed, so that's your first clue. Whenever we have a normal distribution, we want to pick up the mean. So we can assume this is population mean of 280, and our standard deviation, which is sigma, and that is 12 yards. Great, now we want the probability that a randomly selected drive is between 290 and 300. Whenever we have a normal distribution question, we want to standardize the results. And what that means is we can take a bunch of different sets of data, so whether it be drives on the PGA Tour, weights of people in a certain class, average GPAs, anything like that, and we can bring them all to sort of compare apples to apples by bringing them to the standard normal distribution. So the way we do that is we calculate our z-scores. Let's draw a quick picture of what we're dealing with. So we know it's normally distributed, something like this. We know our mean is 280. And what we want is the probability of falling between 290 and 300. So I'll say 290 is here, just slightly to the right of 280, and 300. So we want this probability here. Remember, probability in a normal distribution is just area under the curve. So we need to find that. Let's standardize these scores. So these are, we can think of these as our x values. Now let's standardize them, so bring them to our z values. And the way we do that is z equals x minus mu over sigma. This should be a memorized formula. So x is our data point, so we want 290 minus 280, which is our mean, over 12. That's 10 over 12, or 0.83. So that's one z-score. The other z-score, called z2, is the one for 300. So we can put 0.83 under the 290, because that's our z-score for that. 300 minus 280 over 12 equals 1.667. So we'll call it 1.67. 1.67. Now, how do we get this particular probability? Well, we can look our z values up in the table, and we can get the probability to the left. So all we want to do is take the probability that z is less than 1.67, because this will give us the probability to the left of this point. So all of this area. And if we look that up in the z table, we get 0.9525, which makes sense. It's about 95% of the total area is to the left of this 1.67. Now we also want to know the probability that z is less than the 0.83, or less than the 290, because that'll give us this portion. So then we can just subtract the two and we'll be left with the portion we want. Looking this up in the z table, it's 0.7967. Again, this should make sense. There's less area to the left of 290 than there is to the left of 300. And then just simply subtract the two. So 9525 minus 0.7967, and that equals 0.1558. So what that's saying is there's about a 15.5% chance that we land in here between 290 and 300 for any random drive. Important points here: take your x values, or your x scores, or the values that are actually given in the actual distribution, and convert those using this formula to z-scores so that we can compare distributions across any sets of data. Then z-scores are the ones we look up in the table to find the associated probabilities to the left. So every x-score has an associated z-score. Every z-score in the table has an associated probability to the left. And drawing the picture helps you see this. Hopefully that was helpful. You can always email us more, info@arnoldtutoring.com.